Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, my name is Ali. I'm your physics teacher, and in today's session, we are going to discuss a topic of physics of 10th class, chapter number 12, geometric optics. And our topic of discussion is human eye. In this topic, you will shortly learn the structure of human eye and how the image is formed in a human eye. Students, in a human eye, what is the structure and how it works to form the image, how we can see the objects. Human eye acts like a camera in place of thin film. The retina records the picture. The eye has a refracting system containing a converging lens. The lens form an image on retina, which is light sensitive film at the back of eye. In camera, distance between lens and film is adjusted for proper focus, but in eye, the lens changes focal length. Students, in this point, you have to keep it in mind that we can focus the image not by moving the lens, by changing the focus of the lens. You have learned in the previous lectures that the lens of eye can change its focal length by being too long or short, or thick or thin in size. Light enters the eye through a transparent membrane called cornea. The first layer or the first membrane, which is cornea, which is a transparent layer through which light can pass, and after this the iris is the colored portion of the eye and controls the amount of light reaching retina. Means it has an opening at its center called pupil. Simply, you can say that iris controls the light. When light is more than the requirement, it will contract to smaller size, and when light is less than the required amount, it will increase its size to let the light enter through the pupil. In bright light, iris contracts the size of pupil, while in dim light, pupil is enlarged. Then eye has a convex lens, the converging lens. The lens of eye is flexible and accommodate objects over a wide range of distances. Students, this point means that the focal length of this lens can be changed according to the increase or decrease of the distance of the object from the lens. It can focus the image on the retina without changing the position of the object. So it's in the diagram, you can see that this portion cornea, then you can see the iris and pupil, and then this white colored portion is the converging lens through which rays of light from the object are passing, and after refraction they will meet at a point at the retina where it will form the image, and then this image is transmitted to the brain, and brain will show us the erect image of the object. Students, there are some defects in human eye which we already know, that we used to say that some people cannot see a distant object, some people cannot see near objects. So there are two types of defects. Definition of near point, and before this we have to learn there are two definition of what is a near point and what is far point. That how at a maximum distance I can see, or at the smallest distance I can see. Definition of near point is: the near point of eye is the minimum distance of an object from the eye at which it produces a sharp image on the retina. Means sharp, you can see a clear image which can be seen clearly. For people in their early 20s with normal vision, the near point is located about 25 centimeter. It increases at about 5 centimeter at age of 40 and roughly 500 centimeter at the age of 60 years. Means you can say that with the increase of age, your near point also increases. Means if the objects are closer to you, you cannot see them more clearly at the more age. Then what is far point? The far point of human eye is maximum distance of distance object which can the image be formed clearly. It is as we can see very distant object, so we say the far point is at infinity. Like you can see the stars on the sky, then the distance cannot be measured. It is considered at infinity, so the value of far point is at infinity. So what is accommodation? The variation in focal length of a lens to form a sharp image on retina is called accommodation. Means if the object distance increases, then the focal length of the lens also increases. and it will form the image on retina. Because as we know, if the object distance increases, the image comes closer to the lens, but to make it focused on retina, the focal length of the lens must be increased. And when object come closer to the eye or the lens of the eye, the focal length of the lens should be decreased, so the image can also be formed on the retina again, so it can be seen clearly. So this variation or change of focal length to keep the image on retina is called accommodation. Students, our next point is defects of vision. The inability of an eye to see the image of an object clearly is called defect of vision. You can say when an object is not clearly seen by the eye, then there is a defect in your eye. There are two types of defects. The first defect is nearsightedness, called myopia. Some people cannot see distant object clearly without the aid of spectacles. This defect of vision is called short-sightedness or myopia. What is the reason why this problem occurs in eyesight? It is due to the eyeball being too long. Light rays from a distant object are focused in front of retina and blurred image is produced. Means the light rays or image is not focused on retina, instead it will be in front of retina. How it can be cured, or the correction of this defect? It is corrected by using a diverging lens. Because image is in front of retina, we have to diverge the rays, so they will meet at the more distance than before. Right rays, to observe these rays appear to come from a far point and are focused on retina. The diverging lens is used. In other words, you will say a concave lens is used to cure this disease. Students, you can see here in the diagram that the eye with the defect of myopia, that image is forming in front of the retina. Then in the last diagram, you can see we have placed the concave lens, and it diverges the rays in such a way that they will meet at exactly on retina, and image is formed on retina and we can see it clearly. Students, the next defect of vision is farsightedness or hypermetropia. This is the disability of eye to form a sharp image of nearby objects on retina is known as farsightedness. Means the object which are closer to us or near the eye cannot be seen clearly. Why this defect occurs? It is due to the eyeball being too short. Light rays from a near object are focused behind the retina and blurred image is produced. How this disease is or defect is cured? It is cured by or corrected by using converging lens, or other words you can say convex lens. Light rays from a nearer object, the rays will converge before entering the eye. To the observer, these rays appear to come from a near point and are focused on retina, and thus forming a sharp virtual image. So as you have to see this whole process in the diagram again. There the rays are normally focusing on retina, but in case of defected eye, the rays coming from the object are focused behind the retina, and to focus them on retina we have to decrease the diverging of rays. We have to converge them, and for the converging purpose you all know that the convex lens is used. So convex lens is used here to converge the rays to meet at retina and form the clear image of the object. In this way the farsightedness of eye can be cured. Thank you. Hopefully the concepts are clear.